Inverse Laplace transform. In today's class, we'll learn about introduction, definition of inverse Laplace transform, standard formulae of inverse Laplace transform, and illustrative examples of inverse Laplace transform. We'll see the details of these 4 points now.
Inverse Laplace transform. Let Laplace of f of t is equal to f dash of s. We know that Laplace transform of given function f of t will get what here? F dash of s. So this is nothing but a Laplace transform. But what is inverse Laplace transform? We'll see now. Then f of t is defined as inverse Laplace transform of f dash of s, and is denoted by L inverse. This you remember, L raised to minus 1. L raised to means you shift this L to the right hand side. What happens here? It will become L inverse of f dash of s. This L, if you shift to the right hand side, it will become 1 upon L into f dash of s. 1 upon L can be written as what is L raised to minus 1. So that is L raised to minus 1 is nothing but inverse Laplace transform symbol, or it is a denotation. So L inverse of f dash of s is nothing but a notation for inverse Laplace transform. If L inverse of f dash of s, then we are going to get what here? F of t. So remember, the given function, if you apply Laplace transform the given function t, so if you apply Laplace transform to that, we'll get answer in terms of s we have seen in the Laplace transform. If now onwards, if you apply inverse Laplace transform to the given function s, we'll get the answer in terms of t. So this conversion from s to t is nothing is going to called as what here? Inverse Laplace transform. Inverse Laplace transform can as well be regarded as the reverse process of finding the Laplace transform of a given function. Means here I can say that, so reverse processing, whatever we have the formula or results, if you reverse those things, that reverse process is nothing but we can say that what here? Inverse Laplace transform. Means whatever Laplace transform is there, if you reverse it, that process of reversing is nothing but what here? Inverse Laplace transform. It is just like what here? Our trigonometry and inverse trigonometry. So exactly what we have here, Laplace transform and inverse Laplace transform. So now we'll see what are the important formulas for inverse Laplace transform. So but remember, so Laplace transform is what here? Function converting from t to s. But here in inverse Laplace transform, we will convert the s function in terms of t. So that process is nothing but what here? Inverse Laplace transform. Now converting function from s to t is nothing but what here? Inverse Laplace transform. We'll see the table for inverse Laplace transform. Table of inverse Laplace transform. So we have function f dash of s, and Laplace inverse of this f dash of s, what resultant will get, we'll see here. So here the function f dash of s, that is what here? So 1 upon s is the function here. So we know that what is Laplace of 1? See, this is the result of what here? Laplace of 1. So reverse of this is nothing but 1. Means L inverse of 1 upon S is nothing but 1. Or you know that Laplace transform of 1 is 1 upon S. So this Laplace transform, inverse Laplace transform of 1 upon S is nothing but 1. First formula. Second one, 1 upon S minus A. Inverse Laplace transform of 1 upon S minus A. So minus A is here. So at that time what will get? E raised to AT. We'll get what here? E raised to AT. So if 1 upon S plus A if we get, we'll get E raised to minus AT. Or 1 upon S plus A, if it is there, we'll get what here? E raised to minus AT. So remember, if 1 upon S minus A means inverse Laplace transform of 1 upon S minus A, if it is there, we'll get what here? E raised to AT. And if it is inverse Laplace of 1 upon S plus A is there, we'll get E raised to minus AT. Or else I will write L inverse of, we get this result, and here L inverse of, if it is L inverse of 1 upon S minus A, we'll get E raised to AT. If L inverse of 1 upon S plus A is there, we'll get E raised to minus AT, any one of them. Now next formula, Laplace inverse of S divided by S square plus A square. We know that in the numerator, if S is coming, it is always cos. So S square plus A square plus sign is coming means it is trigonometric function. So therefore I can say that the resultant is what here? Cos of AT. Next, Laplace inverse of S divided by S square minus A square. If it is minus sign and in numerator if S is coming, at that time it will be cos of hyperbolic of AT. So remember the formula here correctly. Next, Laplace inverse of 1 upon S square plus A square. So if I take A instead of 1, if I take A here, it is nothing but result A upon S square plus A square. So Laplace, it is nothing but a result of what here? Laplace of sine of AT. So here A is missing, that A will multiply here. So it will become, so this is the result of Laplace inverse of 1 upon S square plus A square is nothing but, it will be sine of AT divided by A. This A, it is nothing but came from here. So A divided by S square plus A square, this A I have multiplied here. So it will become sine AT upon A. Next, because of plus sign we got sine of AT, and Laplace inverse of 1 divided by S square minus A square is nothing but what here? Because of minus sign, sine hyperbolic of AT divided by A. So we got this formula. Next, as we know T raised to n formula. So T raised to n formula, what we have here? It is n factorial divided by S raised to n plus 1. Okay, so we know that Laplace transform. So I will take Laplace inverse of 1 divided by s raised to n plus 1. Here n factorial is missing, that I will cover here. So it is nothing but what here. So it is the formula for what here, t raised to n. T Laplace transform t raised to n is 1 upon n factorial divided by s raised to n plus 1. We know that. So here n factorial is not there, so it will come here, n factorial. And one more formula of the same we have what here, Laplace inverse of 1 upon s raised to n plus 1 is nothing but what here, because of if n raised to t raised to n divided by gamma of n plus 1. So this will use what here, gamma. So this will use when it is our n value is 1, 2, 3, so on. And this will use what here, t raised to n, gamma of n plus 1 will use when what here, if n is I can say that if it is less than minus 1. If it is less than minus 1 means it will get in usually in a fraction form. So if n comes in fraction form, that is p by q form, at that time we'll use this last formula. If it is whole number with positive whole means whole, positive numbers, will use what here, t raised to n. So remember, same formulas whatever. See, now I will recall once again. As we know that Laplace of 1 is nothing but 1 upon s reverse form. Laplace of e raised to at is nothing but 1 upon s minus a. If Laplace of e raised to minus at is there, we'll write what here, 1 upon s plus a, reverse form. So Laplace of cos at is nothing but s upon s square plus a square. Then next, Laplace of cos hyperbolic of at is nothing but s upon s square minus a square. Similarly, Laplace of sine at is nothing but actually a upon s square plus a square, but a I have taken here, and because a is a constant, Laplace of sine hyperbolic of at is nothing but a upon s square minus a square, but a I have taken here. So Laplace of t raised to n is nothing but n factorial divided by s raised to n plus 1, but n I have taken here. In means inverse Laplace, it will come like that. So in general I can say that, so these are the formulas for our inverse Laplace transform, which one we are going to be remember to simplify the examples. Now I will just see a few of the practice examples based on these formulas, so that we can understand the actual concept, what is the Laplace inverse Laplace transform. Now we'll see the first example. So inverse Laplace of, that is Laplace inverse of 1 upon s minus 1. So inverse Laplace of what here, 1 upon s minus 1 is nothing but e raised to, it is nothing but minus means you will get plus here, e raised to plus t. Next, second example I will take. Laplace inverse of 1 upon s plus 1 is nothing but s plus 1, because it will become e raised to minus t. Next, if question comes, Laplace inverse of s divided by s square plus 9. So remember, if s is coming, it is cos. If plus is coming, it is trigonometric. So s divided by s square plus means this is of the form what here, either sine or cos. Because of s is coming, it is cos, and plus is coming means it is trigonometric. So here, so the value of a, so the 9 can be written as what here, 3 square. So I will write 3t. Next example is, for example I will take Laplace inverse of s divided by s square minus 16. So what we can write here, because of minus sign and because of s, it will become what here, cos of hyperbolic. Okay, because of minus sign and because of s cos of hyperbolic, and 16 is nothing but 4 square, so I'll write 4t. So next example is, so Laplace inverse of, the question is 1 upon s square plus phi. See, because of s square plus phi, it will become what here? Sine. And because of plus sign, it is sine. So sine of, we'll see. So what is the value of a here? Value of a, but this is phi is not a perfect square. But we can write this one as what here? Root phi square. So I will write what here? Just for introducing here. So root of phi whole square, we can mention this one. So root phi whole square is nothing but phi only. We'll get back to the question. So value of a will be what here? So it will be root of phi t divided by value of a. Value of a is what here? Root of phi. So remember the formula and follow up here, so you will understand. So similarly, next result is inverse Laplace of 1 divided by s square plus 25. So it, because of s square plus 25, I will say that it is sine, and because of plus sign it is trigonometric, and 25 is a perfect number, so I can say means a perfect square number, so I can say that 25 can be written as phi square. So I'll write phi t divided by value of a, that is phi. Next example is inverse Laplace of 1 divided by s square minus 36. See, this is nothing but again because of minus sign, s square is there. Because of minus sign, I will write sine. Because of minus, it will become hyperbolic. And 36 is nothing but 6 square. I will write 60 divided by 6. So in this way, we need to remember the formulas of the inverse Laplace transform. Now, next I want to again few more examples based on our formula. So inverse Laplace of 1 upon s raised to 4. So I will write this one as L inverse of 1 upon n s raised to n plus 1 form, s raised to, so 4 I will write 3 plus 1, that is n, formula is what here? 1 upon s raised to n plus 1. So I can say that value of n is 3 here. So therefore this is the result of what here? T raised to 3 divided by 3 factorial. So if you write in this form, so I can say that we will get the value of n, so that we can write it here. Now similarly, one more example, inverse Laplace of, if I take 1 upon s raised to 3 by 2. So inverse Laplace of 1 upon s raised to 3 by 2. We will write it as what here? It is s raised to 1 by 2 plus 1. 1 by 2 plus 1, because s raised to n plus 1 form. So if you write a 1 by 2 plus 1, it will become what here? 3 by 2 again. So from this we will get the value of n. So I can write that what here? T raised to 1 by 2 divided, because of this fraction I will write this one as what here? Gamma of 1 by 2 plus 1, or just I will elaborate. So t raised to 1 by 2 divided by gamma of 1 by 2 plus 1 is nothing but what here? It is gamma of 3 by 2. So actually we need to simplify. So you can simplify here only also. So it is t raised to 1 by 2 divided by gamma of 1 by 2 plus 1 can be written as what here? 1 by 2 of gamma of 1 by 2, which is nothing but t raised to 1 by 2 divided by 1 by 2 into gamma of 1 by 2 is nothing but root of pi. So this 2 will go up, so we'll get the result. Just it is a simplification. So how it works out by respective formulas now here. So these are the very important things we need to remember while simplifying the examples of inverse Laplace transform. So I can say that just remember the Laplace transform formulas, and you will, and based on that you will see how to write the inverse Laplace transform. Only in case of sine, Laplace transform of sine and Laplace transform of t raised to n. So in Laplace transform of sine, that value of a will come in the result, and n factorial of gamma of n plus 1 will come in the result here, whatever we have in the reverse form. Others will go as it is. A reverse of the Laplace transform is nothing but what here? Inverse Laplace transform. So problems we'll see in the next lecture.